This is the solution to number 3 on page 657. If you take a look, we have a quadrilateral. There's nothing particularly special about this quadrilateral. It's not a parallelogram, it's not a rectangle, not a trapezoid. We don't know any special information about it. So what I would recommend doing is dividing it into shapes that we do know. So if we take a look, I'm just going to sketch it, so excuse the sloppy. So this is 104 degrees, this is 78 degrees, 124 centimeters, 115 centimeters, 95 centimeters, and then 104. Centimeters, which this is 100 degrees, not 104. Sorry about that. Good thing we didn't get too far into the problem. Okay, so like I said, if we were to divide this into two triangles, we have more of a chance of finding what we need because we have 1/2 base times height, and base and height and perpendicular, and we've been doing a lot with right triangles. And so what I'm going to do is I'm going to keep these angles whole, and I'm going to divide this into triangles going this way, okay, along this diagonal, so that all of the information that we're given stays, like I said, whole. And so again, I want the information that we're given whole. And so if we're looking at area equals 1/2 base times height, I need a height. And so I'm going to go ahead and from here, I'm going to draw in this altitude, this height, which goes from a vertex and meets at 90 degrees here. And hopefully you watched the how to derive the law of sines. It all has to do with finding the height. And so if we're looking at this angle of 78, the height would be opposite, and this would be the hypotenuse. So we have sine of 78 degrees is equal to opposite, which is h, over its hypotenuse, which is 124. And so how do I get the height by itself? I'm going to multiply both sides by 124. And so the height of the triangle is equal to 124 times the sine of 78 degrees. Now I'm not going to plug that into the calculator yet because this will be a decimal. But if I'm looking for area of this triangle right here, so I'm going to go ahead and highlight it in green. Okay, we have area equals 1/2 base times height. So my base is right here, right? It's always a side length, and it has to be perpendicular to the height that we found. So area equals 1/2 times your base, which is 115, times the height, which we found right here, which is 124, times the sine of 78 degrees. All right, so that is the area for one part of this whole shape. And so now we want to do it again with the other side, okay? And so let's take a look at the pattern that we found here, right? This is the degree of the angle, and so we have sine of the angle, and then these two are the surrounding sides. So we have 115 and 124, and then the 1/2. And so part of, if you looked in the book, one of the investigations, right? It talks about how to find the area of these triangles. You can see these images over here. If you have a base or a side, an angle, and then a side. And here we have a side, an angle, and a side. And here we have a side, an angle, and a side. If you went through and explored that, we would see that it's always sine of the angle. And we're multiplying by the surrounding sides, and then multiplying by 1/2. So it's 1/2 times A times B times the sine of angle C that's in between it. And so that's what we're going to continue to use as we go through this next part here. So if we're looking at this triangle, that I'm highlighting here in pink, we have that. We have side, angle, side. So this area is equal to 1/2 times side times, you can't see that, times the sine of the angle in between, sine of 100 degrees. And so we can get each of these, find the area to the nearest square centimeter. So we're going to go ahead and plug these into the calculator. Okay. So we have let's see if we can get this a little bit further over. Okay, so 0.5, which is 1/2, times 95 times 104 times, and then we always want to do, in this type of calculator, we want to do the degree first, 100, and then press the sine function, and then press enter. So this area is, and I'm going to keep the 2 decimals just so I get a little bit more accurate. So we get 4,000, area equals 4,864.95. And now I'm going to do the area in green, and then I'll add them together. So we've got clear. We've got 1/2, so 0.5 times 115 times 124. 124 times the sine of 78 degrees. So we want to do the 78 first and then press sine, and then equals. And so we've got 6,974.19, and I'm going to add this area in pink to it. So plus 4,864.95. And this is why it's important to kind of go to the decimal on here, because we can see that we're staying the same with that 1/4. So we've got 11,839. So the total area is equal to 11,839 centimeters squared.